Thanks, Tomáš, for already heating up the audience. So I will basically build up on the foundations that Tomáš laid. And I will talk about ways in which you can basically secure your networking traffic or encrypt or any other ways to make sure if there are some bad guys in your cluster, then you can tell that your traffic and your data is safe. So a little bit of introduction. My name is Tomáš, as you already know, as the other Tomáš. I work at Prusa Research, and I have already told you the scope of this talk. So, security. Let's lay down some general concepts. Yeah, security is like an onion. You peel away the layers and try not to cry, basically, in most of the companies, I know. So we can think like security in Kubernetes, we can break down to several layers, so to think of. So first of all, we can think of the build time security, then the deploy time, and then the runtime. They are completely different topics with different aspects, different challenges, stuff like that. I will just pick one small part of this whole set because we will be like a few days in here. So the build time. Stuff we can take care of is like scan our images, harden our operating systems, basically to minimize the attack surface, either by using like the distroless containers, if you already use container, which I hope you use, or basically build from scratch. Basically just to leave as few code that you are based on as possible, because minimize the attack surface. Then the deploy time, again, some Kubernetes cluster hardening. You can utilize tools like Kubebench, and then the other part would be like utilizing a few security tools, basically like all the stuff related to networking, being at the firewall or some security groups. So if you like host clusters in your private data centers or cloud, you have some sort of way to isolate like network-wise, either your nodes or stuff like that. And then the most interesting part is the runtime security, which can be break down to few components. The first one could be the network security controls. We can break them down to the different layers, as you see in the OC stack. So layer 3, 4, there are tools like Calico, WeaveNet, Entra, KubeRouters, stuff like that. Cilium also as well. And the L7, basically everyone knows the Envoy proxy, I think. Then we move up more enterprise-wise, and we have like bigger and better tools. We can encrypt data in transmit. We can use like MTLS, WireGuard, IPsec, and stuff like that to encrypt the traffic, really, not to just like isolate the network. And yeah, if you run in enterprise, you possibly need to do some compliance stuff. And basically, at that point, you need to have data encrypted. And yeah, and the other thing is you need to defend against the threats out there with IDP and IPS solutions. You can do it with your software, or you can have like dedicated physical machine that does the intrusion detection or prevention. Cisco, I think, made a few of those. So, yeah. Kubernetes itself has some some of those mechanisms built in, like security-related mechanisms. Everyone, I think, knows the network policies, pod security policies. You have like Kubernetes secrets, which are not that much secret, you know. We have basic RBACs. You have cluster roles, etc. You have some sort of authentication against the Kube API server or stuff like that. You can use certificates, tokens, JVTs, passwords, whatever. You can configure TLS for your ingress, and you can configure quality of service. That's built-in stuff. So you can just take it and use it. So the question, why do we need to secure the traffic? And why the encryption should be like essential to protect against the bad guys, and what are the options we have besides the built-in? The reason could be you are running your workloads or basically hold your cluster in the untrusted environment. So you borrow some machines from some data center and you run your clusters there. You really don't know what's happening like there. The other thing is you could be sending some personal information data, which is another like lawyer on your neck. So you need to have the data secure. And the most important part is if you encrypt the traffic, you can say it's cool. And you've done that. And the real reason for encryption is the compliance, as you know, because there are rules. So as we are already here familiar with the CNCF, as you would guess, CNCF has some great tooling which you can just plug and play and use for securing your traffic in your cluster. Most famous options when you talk security is first one should be like the MTLS. There are projects that basically enables you to use MTLS like with few lines of code, so it's basically very easy to configure. If you dig deeper in a network layer, you have options with encrypting traffic on the layer 3 and 4 with IPsec or WireGuard with different CNIs. And then you have like the network policies management using like the open policy agent, Kyverno, and the new thing like the admission policy. So let's dig into encryption a more. So what are the common challenges we face when we basically need to encrypt the traffic? So how do we tell which like service communicates with which service? How do I enforce some rules? You basically heard of network policies before. And how do we put a security in such a place? And then how do we observe it? You already know the Hubble. General answer would be use the service mesh. It provides all the stuff out of box. And behind the service mesh, there's a bit of history. Main reasons to like implement was like the application needs to communicate to like many other, because you have like the microservices and applications has like many components. You can do nice things like canary rollouts. You can do like load balancing, rate limiting. You have service discovery, all the nice stuff. And you have MTLS. Basically, you don't need to configure anything, just plug and play and use it. It's all very nice, but as history proved us, it's nice until you get the first bill from your provider. So you may know most famous service meshes being it like Istio Linkerd. And as I already mentioned, most of the times there's a catch. That's the catch. So what's the challenge with sidecars, or what was the challenge? It adds extra latency to your applications. So if you have like strong SLAs for your application, it may not be useful for you because you just ran out your latencies. It adds non-trivial complexity to your application and to your networking stack. So you need like professionals to be able to work with that and to configure it properly so you can use it. There are some startup and shutdown race conditions which are fairly hard to debug, and you prolong the startup time of your pod because you need to wait for the proxy to be ready. The general flow inside when you have a sidecar is as shown in a picture. You ran through the whole stack multiple times, which is as you would get not that optimal, and you can change it. You can use service meshes that do not enforce you to use sidecars, and the flow through the networking stack will be like this and will be very efficient. If you want to have this on a layer 7, you have the envoy proxy container, so you get through the stack twice, but it's fairly less overhead compared to the previous solutions with the sidecar. So with the MTLS, that's a challenge because there are like ways you can separate the authentication and the encryption part. So you can, the proxy was initially designed to work with TCP, but when you separate, you need to send the TLS data and the, like the TLS handshake and the data through the different channels. As you already heard from Tomáš, Cilium has already like strong layer encryption, but it's all nice until we get to the layer 7, which is the stuff you need to inject the certificate to the kernel to authenticate to the layer 7 MTLS. I think the Cilium has still the beta with SPIFFE identity, which is like very nice effort, but it's still like not there. But hopefully it will be. With the sidecars, there's a bit of controversy. You already heard the Cilium envoy config from Tomáš. The one side of the problem is you can have the one proxy per node, which is like multiplying the number of proxies you need to have. And the other solution would be to have per pod sidecar or the per node proxy. I mean, each of those have different challenges and they are differently implemented. And I think you remember the onion from the beginning. Yeah. So what are the commonly used encryption options? We covered MTLS, which is covered by service meshes, and Cilium also. The other options was the lower on the networking stack, and it was the IPsec and the WireGuard, and we will cover them more in detail. So layer 7, MTLS, already included few lines of code, sidecars mostly, so there's a bit of a downside. I know there's a ambient mesh in Istio which is quite popular, but I think it doesn't allow to use the eBPF in the ambient mesh mode, I think. So there's a bit of a catch always. the very simplified explanation how the MTLS works is that I give a certificate to you, you give your certificate to me, and we both have some predefined mechanism by which we tell that it is trusted. So use some common authority. With Cilium, it was a SPIFFE. And the layer 3 and 4, there are some cryptography challenges. So the hard stuff is how would you manage the keys. You need to generate the key, you need to rotate, and you need to distribute them to your machines. And you probably know the Bob and Alice tale from the old beefy helmet. Okay, the IPsec. The first option, it is supported by Cilium and Calico CNIs, I think maybe even a Flannel. Basically, you store your keys as a Kubernetes secret. You have one pre-shared key which is distributed for all your nodes. And the Cilium implementation specifically use the XFRM frameworks, which is like very efficient kernel implementation of IPsec. And if you want to like test, if you configure it correctly, you can like TCP dump the traffic and search for ESP packets. The bad thing is you need to take care of the key rotation. So each time you rotate the key, you need to patch the secret or have some mechanism you can like rerun it, and you have to bump the key ID. So a very simple example, you can configure some like cron job which does the stuff. I'm not aware that like Vault or stuff can do something like this, like patching it. And the other more interesting option of encryption in layer 3.4 would be to use a WireGuard, again supported by Cilium and Calico. The thing is, the WireGuard is very, very opinionated. It has like very robust cryptography built in, but as it is opinionated, it doesn't allow users to choose their ciphers, protocols, which you can in IPsec. It's operationally very simple, so you don't need to take care of rotating your keys. It does it for you. The encryption key pair is generated by Cilium in this case for each individual node, in contrast to IPsec, which you have like one pre-shared key for all your nodes. The key rotation itself is performed by WireGuard kernel module with the forward secrecy built in, which is kind of interesting topic, and I will cover it more deeply. The bad thing is it's incompatible with L7 policy enforcement and network policy rules. So basically, if you encrypt the traffic on your layer 7, you have no visibility on HTTP with a Hubble. It's pretty much supported like kernel 5.6 plus, and it was backported. So basically, every new distribution has support for WireGuard. So another hassle to take care of. If you deploy it and want to test it, like send some health checks with your pods from one node to another, again, you can test it by TCP dump and search for WG0 interface traffic. And each node creates its own encryption pair, as I already stated. So as I told about the perfect forward secrecy, which is a very, very nice thing that WireGuard has, the way it works is you use the public key, to encrypt and instantiate the new key for one session. It means like every message you send through WireGuard, you have like the new set of keys, So even if someone like stole the certificate for you, he doesn't have the pre-shared key, and even then it's only valid for that participants in that certain message. So even if someone like steals your data, he cannot be able to decrypt it lightly. Or he can decrypt just the very certain message, so you basically minimize the attack surface, which is kind of nice. And if you follow correctly, we have some common denominator with the tooling that could be used to provide all those functionalities like IPsec, WireGuard, MTLS, and which one would be? Any guesses? Oh, yeah, the one with the B. You saw the B, yeah.
Oh, there's the B.
Yeah, there's a B. There's a B in every slide, yeah. You can search for it. Okay, yeah, it's Cilium. So, Tomáš already covered a few killer features of Cilium. My takeaway was the strong encryption it allows you, but it can do like way more than that. It understands and you can filter the network traffic. We already saw like HTTP protocols, Kafka, gRPC. It can do Cassandra and stuff like that. It's aware of Kubernetes like identities, so you don't need to search for your IP addresses in your log files, and you can basically search for your services and pods and stuff like that. It is really nice. And when like deploying the encryption stack, I told the setup is like pretty easy. It's just one flag when installing the CNI, and just bam, it's there. We already heard the Cilium ecosystem and the tooling around. First one, Cilium, the CNI, Hubble, visibility tool, Tetragon. It's a thing that we can talk about it like for a very long time. It's the security observability tool and the enforcement of the security, even at runtime, which is very nice because everyone can like configure some network policies and some rules when you have like inspected traffic and I see, yeah, that's a bad one, I will block it. That's cool. But in the runtime, that's a whole different story. Tetragon can do that. Yeah, cover that. Hubble, you see already the demo. Yeah, Tetragon, as I stated, is the youngest product in the family, but it has a really great potential, I think. A lot of features are in the enterprise only, but I think it's getting there. eBPF, already heard of. There's a B already. Okay, we covered MTLS, we covered WireGuard, we covered IPsec, very much options you have to like secure or encrypt your traffic, being it with the natural Kubernetes object or using some tooling around. So what Cilium adds to that, the first thing is you can replace the key proxy with the BP filter by the eBPF. You can configure mutual authentication, MTLS ready out of box, so traffic secured perfectly. It can do load balancing, traffic encryption, which was our main topic, service mesh, etc. Very long list to cover. And if you try and get stuck, documentation is awesome. See that? There's even a Slack channel on CNCF, so you can basically reach the guys from Isovalent/Cisco right now, and they are very helpful. They have very curated list of news called Eco. If you like subscribe to their newsletter, that's very curated and up to date list of news related, very related, and the community is great. So go ahead and try that. And that's a bit about me. And that's it from my side. So are there any questions?
Wait a moment.
Yeah.
Okay. So I think there's no question. So is there any? Okay.
Yeah, slightly.
You can ask.
You can ask, yeah.
In the past, we have used WireGuard just to encrypt internal communication.
Mhm.
Like we trusted the nodes themselves, like when the pod is communicating with another pod on the same node.
Yeah,
Yeah,
you
it's
cannot
trusted.
encrypt it with WireGuard. Yeah, that's on the same node. I was talking like the cross-node traffic, like the pod to node or node to pod and stuff like that. Like
Okay,
the
so
cross
there's,
node. Yeah.
I can like turn it off. So because I'm afraid of the overhead of encrypting the messages inside one node, which we don't consider like to be necessary.
I mean, yeah, it's when you are on the same node, you have like a bunch of pods there. It's like flat network, and if like something goes wrong, you can pivot like stuff around, and yeah, it can go pretty badly. But since WireGuard is like already implemented inside the kernel, I don't necessarily think there will be like much overhead for your traffic and besides latency.
Okay.
Don't have the numbers to tell you.
But is there an option to turn it off for like internal communication?
Within one node?
Yes, within one node.
I don't think so.
Any other question?
I mean, you configure the host operating system, so well, like not that much, but you configure the nodes that are in this case like managed by CLIM agents. So yeah, basically the node Kubernetes. So you encrypt the traffic from one node to another, and the pods deployed on them.
So there is no any automatic key rotation in IPsec implementation in Cilium, like Pluto or strong Sven daemons have for changing.
For IPsec?
Yeah, for IPsec.
I'm not aware of that.
So only
Maybe you
manual.
can correct me? No, it's not. I mean, you can like build your own service to do it, but it's not like built in.
So, no other question? Okay, so I have one. So, yeah, security is nice.
Yeah,
Everybody wants it.
yeah. But after the
But-
incident, yeah.
But I'd like to know if you have any number, for example, or guess, how many companies does it implement it? I mean, some kind of security inside in the Kubernetes cluster. I don't mind to think like across more Kubernetes clusters via via proxies, but just in the Kubernetes.
Yeah, that's a very nice question. I mean, I don't know, honestly. I think the number would be like lesser than I would like to be, but I think many companies do their like security with network isolation and not necessarily like really encrypting the traffic that is flowing inside. So basically like create some network stuff and try not to allow anyone from the outside to break in. And when someone breaks in from the outside or from the inside, you are basically screwed. That's I think the story of most companies, because the security comes at place just after the incident.
Okay, and I have one more question.
Yeah.
So I said that I have two options like IPsec and WireGuard. Just for a while, forget that there is the issue with the key rotation.
Yeah.
What will you choose, and why?
I mean, WireGuard would be faster, more efficient, already implemented inside the kernel, so you have like no work to set up it. Yeah, IPsec, basically the same, but I don't like the thing you have the same pre-shared key on each node. That's the thing, and it doesn't have the forward secrecy that which. Yeah, you can configure. Yeah, sure, you can configure the hell up everything. Yeah. Tough question. I mean, in a real life, I would turn off the mic, not choose anything, because you lose the visibility, which is the main not selling point from my point of view.
Yeah, I also wanted to ask about the additional latency and also the availability, because WireGuard is UDP, so
yeah, it's eventually consistent, or maybe not.
Okay, yeah. I think that's it. If there's no other questions, so I'd like to thank Tomáš